like this one had quiz website, I'll have 3 different links for submission. So you just won't submit certain ones. If you don't want to do, say, the quiz primer math one, just leave it blank. Don't put anything there. Because remember, I'm keeping your grades outside of Blackboard. I'm keeping track of all that stuff. It won't give you a 0. It'll just disappear when that assessment is not there anymore. Does that kind of make sense? I think I'm freaking you guys out. I apologize if I am. I got it. I got this. Okay. We're good. We're good. Don't worry. Don't worry. All is well. Okay. So let's get into the, as John Goodman says, class problem. Today is going to be a bit of a, today we're going to pick up some ideas today. Now, very often, I put the stuff from the first bit of your book you need to know right now. I'm a huge fan of getting stuff you need right when you need it and not before. And all stat textbooks, for some reason, are written the same way, at least the ones I've seen. They're all written the same way. They teach you a bunch of graphical techniques and a bunch of terminology and a bunch of calculations in like the first chapter. And then like 40% of that stuff, they say, okay, now remember this z-score thing, because later on when we do the bell curve, well, you're not going to remember that. It's like me telling you a string of numbers right now, Michelle, and then saying, in 7 weeks, remember this, because we're going to need it together and walk away. And then they'll talk to you 7 weeks later, remember those numbers? What the hell, why not? It's ridiculous, right? So what I'm going to hit you with today is just the stuff you need to know for the next week and a half, and then we'll start adding the other stuff in when it's pertinent. So there are some terms you're going to want to know right now, because they're going to be terms we're going to use throughout, like the word data, which I know you have heard, through your lives. And the best definition that I can come up with is it's information. And you probably collect it. I mean, you don't have to collect it. Even if you don't collect it, it's out there. It's that whole tree falls in the forest, does it make a sound? Of course it does, you just don't hear it.
How do you know that?
Because you don't hear it.
But you're not there, so how can you
Oh, David, so we need coffee sometime. Obviously, we need to drink coffee and talk about this sometime, right? I'm speaking like a statistician, not a philosopher. Because every tree that has fallen, I have heard, therefore I conclude. I love this stuff. So, even if you don't collect it, the data's out there. Even if the tree doesn't make a noise, it falls.
Well, the sound wave still goes, just gets really quiet.
We'll have a standing coffee date for after class. How's that sound? They're good? All right. One of my students actually collected on that from 2 years ago. It's pretty fun. So, anyway, I want to break the data down today. A couple different kinds, because it's helpful to know what kind of data you have so you know what you're allowed to do with it. The first one I like to talk about is qualitative. Sometimes people call it attribute. This is non-numerical data. Non-numerical data. So, for example, the color of something. You want to keep track of the color of something. Or the town one lives in. Or, did you, yes or no, buy food while you visited Bend? The reason I'm bringing all these up is I'm currently developing a survey for Bend Film. I don't know if you guys know about Bend Film. Local film festival, right? Bringing up all these independent films. I'm building their survey so they can collect data so they know how better to market Bend Film. It's full of qualitative data, full of it. Because they want to know, hey, for example, what town did you come from? Did you come from Bend? What section of Bend did you come from? Are we catering more to West Siders or East Siders? Or are we catering fairly universally? But those aren't numbers, right? Those are words or places, towns. Those are words, they're not numbers. Some people treat words like numbers, and we'll talk about that more as we go through the course. You guys do class evaluations, right? And I think part of that is a scale, right? On a scale of 1 to 5, your experience in these, hairstyle, Sean's hairstyle, 1 to 5. Well, the thing is that when you put a 1, it's not really a 1. That 1 means a word. Usually I think it's strongly disagree, I think, is 1, correct? I think so. Strongly disagree. 5 is strongly agree. 2 is disagree. 4 is agree. And 3 means neutral. Exactly, neutral. 3 is cut your hair off. 3 is neutral, I don't have an opinion. So those are qualitative data points. Agree. Agree. You can't average the word agree. But as soon as you turn those into numbers, they appear that you can average them. And then they average them and they say you average 4.2. I'm like, what does 4.2 mean? Does that mean agree 0.2? I mean, what does that? It doesn't mean anything, right? Now, we'll deal with this discussion, but just realize that very often qualitative data is confused for numerical data. Lots of this out there. Those of you in social science, my psychologists, my sociologists, my HDFS folks, yes, there's a bunch of you out there, I think. You're going to be dealing with qualitative data all over the place, right? You're going to be looking at ethnicities, You're going to be looking at levels of schooling, which seem numerical, but if you break it down by high school, elementary school, middle school, not well defined, it really is qualitative. So plenty of qualitative data out there. Not much you can do with it. We'll deal with that on Tuesday, or whatever the next time I see you guys is. Monday. Thank you. Monday, because it's Wednesday. Whew. So that's qualitative. The more interesting one mathematically for us is the numerical stuff, which we call quantitative. And that's kind of fun. Not that qualitative isn't. Qualitative is awesome. There's just not a whole lot you can do with it other than count it up, add it up, and graph it and look at it, which we'll do later on today. Totally. I enjoy doing that, and you will too, especially as humans, as social science majors. I mean, you have to do that. But you're limited with how much you can do. And those of you taking the 244 route with me, or with Donna, taking the 244 route, or with Matt, I guess, a bunch of us teaching it now, you'll learn other ways to take qualitative data and analyze it. And let me make sure this is catching the screen-ish. That's not bad. So quantitative data is numerical. I like to break it into two different kinds. And we'll flip-flop back and forth with this a lot this term, depending on what we've got. The lion's share of the quantitative data you guys will encounter is discrete, stuff that you count. That's the lion's share of what you will encounter in your lives. And a lot of the research you do will also be discrete. If you have to measure something, it's going to be continuous. It's called continuous. Do you have any idea why discrete data is generally more prevalent in your lives than continuous data?
There's a stopping point to it.
Sweet, go with that. I love that. Go with that. Stopping point.
Because then there's an amount that you can say, this is all of it, let's figure it out.
I love this. So you've got 0 or 1 or 2 or 3. If I need to count, for example, if I'm trying to figure out genders at COCC, I simply go, okay, boom, 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 boom. If I need to figure out how many brunettes are in the room, boom, 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 boom. I don't know how to do that. If I need to figure out how many OSU students there are, I have you raise your hands and I go 1, 2, 3, 4. But suppose I need to know the average height of somebody in the room. Is that as easy as just raise your hand, let me count you? What do I have to do with an average height if I needed to know that? I gotta get you all over here against the wall with a tape measure and make sure my tape measure is precise, make sure all those increments are correct, right, and consistent, and then accurately and precisely measure every one of you. Once I have the accurate measurements, the math is easy, but it's getting the measurements that's hard, right? It's getting those measurements. I learned this the hard way with 105 last term. I had a great experiment plan for you guys, dropping balls and calculating the rebound height. And I kept talking about that, and then finally I started doing it, and I'm like, there's no way in hell. Because we have to measure the rebound height. It's so messy. It would take us 3.5 weeks just to collect the data, and you'd hate me by the end of it. So, continuous data is exceptionally difficult to get because measurements are just trickier to do in general than counting. Discrete things are easy to count. I can count the number of cars in the parking lot. I can also measure the average weight of a car in the parking lot. Exactly, but we laugh because it would take infinitely longer to do that, right? I can count how many red cars there are, but I'd have to measure the red content in a pigment. Right? Exactly. We laugh again because you think about that. Oh my God, we have, right, what qualifies as red? How red? Is it more purple? I mean, then it's like, oh God, and then you have to break that down. It becomes a chore. So, countable data, measurable data. Both of them are important. Both are important. Sometimes they masquerade as each other. IQ scores, for example. Do you know what IQ would fall under? Discrete or continuous?
Continuous.
We have a couple votes for continuous. Tell me why, Davidson.
Because it's something that's measured.
What is it exactly? Do you remember?
Intelligence quotient?
It's the intelligence quotient. So quotient implies that it's mathematical because you're doing what? You're dividing. Was that Andrea? Who did I just hear that say dividing? Oh, tell me anything.
Alicia.
Alicia, go ahead. What are you dividing? You remember? It's okay. Divide something, right?
Yeah.
Divide.
The bottom number is your chronological age.
Oh yeah.
The top number is your mental age. You take your mental age, divide it by your chronological age, that's your IQ. And you have to convert it to a percentage. You multiply it by 100 to make it like 100 being average is because that means your brain is just as old as your body is. Now somehow that becomes intelligence. I don't pretend to understand what intelligence is, but that's the calculation they get to get IQ. So a 200 IQ means your brain is twice as old as your body by the IQ test. Now the IQ test is the mental age calculation. It's not just an age, it's an intelligence mental age somehow.
By 1960.
It's fairly dated. We're going to talk about this later on in the course. We get a few more tools under our belt. But it is continuous because it's based on age, and age is a subset of what larger measurement? Time. Time, right? And time is measured. Oh, well, you look at that clock. 1 second. 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 That's getting annoying. I'll stop doing that now. And it sounds like it's discrete because it's stop, start, stop. But it's not. There's no stop. Just because the clock clicks by second. Aren't there milliseconds?
Yeah.
Hundreds of seconds and millions of seconds and things like that. Yeah, it's a continuous sweep. Faith, go. You had a comment. Go ahead.
I was gonna say it's because it's always changing.
It really is, yes. And discrete stuff can too.
Set.
Yes, discrete stuff can always change too, but your definition of always is spot on. If I get from here to here discretely, it's like that. And everything between is irrelevant. I just lost something. There we go. But to get from here to here continuously, it's that, and everything counts. And it gets tricky mathematically because of that. So that's why this, Gallup polls, every Gallup poll I have ever seen in my 41 years of life is a discrete data pool. We'll look at one later. You'll look at one in your quiz for next week should you choose to do that one. So you'll see more discrete than continuous, just by nature of it's easier to get. That doesn't mean it's better necessarily. It could be more vacuous. But we'll get to that too. So here,